This is the video tutorial for lesson 11.4. This is basically the test review in readiness for the test. Now part A actually has nothing to do with this unit at all, so this was actually the warm-up. So if you want to try pausing the video, you could certainly do that and just try those first 2 points. So this question here, as we're asking to differentiate and it's two things multiplied together, that means that this is our product rule. So we should write down what U and V is, and then we should go ahead and just differentiate. Then using the formula U dV plus V du, we can go ahead and substitute here. And you could factor out an x, and you could factor out an e to the 3x plus 2, and that would probably be the best answer then for that question. Now for the second part of this, we can see that this is a quotient, and we've got a fraction there. So this would be the quotient rule. So the numerator is u, and the denominator is v. We would differentiate both parts. So the differential for cosine is negative sine, and the differential of 2x cubed is 6x squared, so we bring that to the front. And then it's still sine of the same thing, so in other words 2x cubed. Differential of 3x is just 3. And then we're using the quotient rule, v du minus u dv all over v squared, giving us this. And you can certainly divide both by 3. There's a GCF there. Not much else though. You could factor out a negative perhaps at the start as well, but that's it. I can certainly see the 2x cubed here, but you can't factor that out because it's actually sine of 2x cubed and cosine of 2x cubed. So these are operators, so you're not allowed to factor that part. Now, the actual first question in the test review is actually this. Given that x equals this, find dy by dx in terms of x for 5 points. Now, we're not going to be able to pick up all 5 points for this question, but certainly the easy points are at the start of the question. So I could just, normally it's tempting to, when you see dy by dx, to want to make it say y equals and then differentiate it. Sometimes it's easier if it says x equals to differentiate it and then just do the reciprocal. So that's actually what I'm going to do. So differential of x would be dx by dy. Normally if it's y, we'd put dy by dx. So for this one, we're going to put dx by dy. Differential of sine is cosine. The differential of 2y plus 6 is 2. Times by the 4 at the start would give us 8. And then this is where I'm saying, if you want dy by dx, you could just do the reciprocal of both sides. So this would turn into a fraction, and it would be 1 over 8 times that. Now, if you can actually get to that point, that's actually 3 out of 5. The last points are actually kind of difficult to do. What we're trying to get, though, is the question says in terms of x. So in other words, we need to solve for y. So we kind of do eventually have to go back to that anyway. So this is what x equals. I can certainly divide both sides by 4. I could do sine to the negative 1 of both sides. That's the reciprocal of sine. Sorry, the inverse of sine, I apologize. We could go ahead and subtract 6 from both sides, and then you could divide by 2. And then from here, you could substitute this whole thing in for y. So 2 times 1/2 would just cancel, and y would just become this part here, and then at the end, we'd still have to add 6 onto it. So dy by dx would equal 1/8 cosine of sine to the negative 1 of x over 4. We've got plus 6 up here. Sorry, minus 6 from here, and then you've still got the plus 6 at the end. So they would cancel, and that would take you to there. And that's only one additional point. That sounds really tough to me. 3 points just for getting to there, and then this is only one additional point. And that's as far as we can go right now. We'll take 4 out of 5 on this one. There is an AP Calc method that's kind of complicated, but I don't think that part's on the test anymore, and 4 out of 5 would certainly be good. You certainly won't be getting anything as difficult as that on your test. The second question is this one here, the 3x squared one. So find an equation to the normal at the point 0, 1. So this is your pretty standard question. They haven't broken it up at all. They've made it out of 7. So, and I've made it a show that question as well if you want to try this question and pause. That's supposed to say is. There we go. So you would differentiate, so 6x minus 4y, as it's a y, dy by dx. Differential of 2x is 2. Differential of negative 3y is negative 3. dy by dx, as there's a y here. Differential of 5 is 0. And differential of 0 is 0. We're trying to solve for dy by dx, but I notice both of them are negative. So I'm going to bring them both to the other side, making them positive, and then factor out dy by dx. And my 6x plus 2, I'm going to leave on this side. And then to solve for dy by dx, you can just divide both sides by 4y plus 3. As we know the point 0, 1, if you plug 0 into here, that would be 0, plus 2 is 2. And if you plug 1 into here, that would give you 7. As the question says normal, I'm going to need the negative reciprocal. And then from here, you can use your point slope formula. It does ask for a specific formula, and it does say a, b, and c are going to be integers. So for this reason alone, I would want to get rid of the fraction by multiplying both sides by 2 straight away. Obviously, x minus 0 is just x, so negative 7x. And x can also not be negative for this either. So if we add 7x to both sides, that would actually meet that criteria. High scoring question, but definitely one I'll be looking for you to do really well on, because I think most of these steps are actually pretty standard. The one thing that kind of did surprise me, though, for this how many points, often you'd have a product in here. So you'd have something like 3xy squared, where you'd have to do a product rule to actually differentiate that term, and then perhaps some of the other terms as well. Question 3. The curve has the equation this. Find dy by dx for 5 points. So this is kind of what I was talking about. This one actually does have a product rule here. So u is the first term, v is the second term. As we differentiate y, that'll give us dy by dx. And if we differentiate e to the negative 2x, we get this. Now, I didn't actually write this one down, but you should be writing down here the u dv plus v du to make it very clear where this is actually coming from. So this part here is just the left-hand side of the equal sign. And although I said plus, we do have a negative here. That's why there's a negative. Differential of 2x is 2. Differential of y squared is 2y. As it's a y, though, dy by dx. Then we can start collecting terms together. So I brought all my dy by dx's to one side, and then I brought this to the other side. So this positive 2y dy dx becomes negative 2y dy dx. And negative 2y e to the negative 2x becomes positive 2y e to the negative 2x. We can take out dy by dx as a factor, and then we can divide by both sides by this term here, and that would give us our first 5 points. Now, there is a follow-up to this one as well, part B, so I actually did write down our answer. Find the equation of the normal to this, giving your answer in the same form, this general form as we saw before. So as it goes through 0, 1, you can substitute in 0, 1 and evaluate that, and that would give you 1 point. Realizing it's a normal, which means you need the negative reciprocal, if you see 1/4 anywhere for the slope, that would be a second point. And the third point is for doing the whole point slope formula, and the last point is for rearranging this. So I would times both sides by 4, and as x is positive, I would bring my other terms to the other side to make this equal to 0. And that concludes the test review. There will be some miscellaneous questions that, if you have time, you should certainly work on. The more practice that you get on this, the better. But certainly knowing those main rules of differentiation is also going to be very important while you're trying to do this exercise.